Right now, traditional higher education is colliding with a massive, rapidly accelerating financial force, the generative AI tutoring market. This chart maps the trajectory of that collision. Right now, the AI tutoring market sits at roughly $2 billion. Over the next 5 years, projections show it scaling to $8 billion, with the broader AI and education sector ballooning from $6 billion to $32 billion. Despite this influx of capital and technology, traditional university architectures are entirely unprepared to absorb it. Institutions currently treat artificial intelligence like a traditional campus library. They point students to external, third-party chatbots and expect them to wander through the digital stacks to find answers on their own. For disciplines like engineering, sending students out to the open web introduces severe risks. Generative models can hallucinate false technical data, and the specific methodology the professor intends to teach is completely lost in the noise. Providing raw access to external AI bypasses academic rigor. It outsources the core function of the university, curated, intentional instruction, to unaccountable commercial algorithms. To fix this, the technology must move from the periphery to the center. AI cannot be an external supplement. It must become the localized, native infrastructure of the curriculum itself. This is the premise of the AI tutoring framework. It is a system built directly into the university's digital architecture. The defining mechanism of this framework is its strictly closed-loop or bounded data environment. Instead of acting as an oracle that pulls from the entire internet, this bounded AI operates solely as a digital extension of the individual professor. By restricting the inputs, the technology adheres to the institution's pedagogical standards, rather than forcing the university to react to unpredictable outputs. Integrating large language models into rigorous engineering programs requires building a fence. The AI's knowledge base is entirely constrained by the professor's explicit methodology. This diagram shows how bounded data flows, starting at the professor console. The human professor uploads their specific, curated materials into a localized engine. An AI co-professor analyzes this data, suggesting structural optimizations in a feedback loop directly to the instructor. Once the instructor approves the structure, the system locks the material down, generating a strictly bounded, compiled knowledge base. When a student is connected to the AI tutor interface, they are placed entirely inside this system. The AI tutor can only reference the compiled knowledge base. It cannot reach out to the open web. If a student requests a generalized answer, the prompt hits this grommeter. The system immediately intercepts the query and deliberately redirects the student back to the professor's specific educational stream. Universities gain the conversational capability of a generative model while maintaining absolute control over the academic narrative. Traditional static grading, giving a student an A, B, or C after an exam, is an obsolete feedback mechanism. It tells the student absolutely nothing about how to correct their individual mistakes in the moment. The AI tutoring framework replaces end-of-term assessments with continuous, adaptive evaluation. This diagram displays the pedagogical engine driving that evaluation. Built on Bloom's taxonomy, the AI tutor constantly analyzes student inputs against this pyramid. If a student fails to execute a concept, the system reacts instantly. It autonomously lowers the complexity of the next prompt, stepping down the pyramid to reinforce basic recall. Conversely, when a student demonstrates clear understanding, the AI elevates the interaction, challenging them with higher-order tasks. Because every interaction is tracked, the human professor receives highly granular, real-time data detailing the exact comprehension level of every individual in the course. By operationalizing Bloom's taxonomy, the language model functions as an individualized feedback loop, ensuring absolute concept mastery before allowing a student to progress. Students arrive in the classroom accustomed to the instant gratification loops engineered into social media and video games. Compared to those digital environments, working through complex engineering problems feels slow, high friction, and unrewarding. To counteract this behavioral friction, the framework integrates a structural gamification engine. As students interact with the AI and prove their mastery of the material, they trigger progression mechanics. Consistent performance earns them status upgrades, moving their profile rank from freshman up to senior engineer. By anchoring academic progression to familiar dopamine reward mechanics, the system sustains focused engagement, even through mathematically dense engineering topics. This timeline outlines the deployment strategy. Moving from pedagogical theory to institutional deployment begins in year 1. The first objective is a targeted internal pilot within the engineering faculty. This phase isolates the software, stress testing the interface, and localized server infrastructure. By year 2, the refined architecture scales outward for university-wide deployment, shifting focus to high-load optimization and server management. This phased rollout guarantees that the technology is grounded in empirical baseline data from real students before broad institutional adoption occurs. Executing this exact pipeline is the necessary mechanical step to transition a university from holding a theoretical concept to operating a fully functional AI-native campus. The window to establish leadership in the educational technology space is closing rapidly. Institutions face a stark choice. Universities must either build proprietary internal frameworks right now or accept they will be forced to purchase third-party external solutions in the very near future. Institutions that build their own bounded frameworks capture massive long-term value. They secure the ability to commercialize and license their proprietary systems to other universities across the global market. Deploying an AI-native infrastructure secures a university's economic and academic sovereignty in the generative age.